Alright, I hope this is working with the mic and everything. Today we're just going to do a screenshot and we're going to go over 6.7, graphing linear equations. This is a grade 8 lesson. When we taught this in class, most students were able to do a quick review of this, so I'll try not to belabor the point. This is a Cartesian plane. We have the x-axis lying flat and the y-axis going up and down. To remember which one is the x, just think that a plane must excel before it can take off. So excel on the runway. So we have point A. It says here that point A is coordinates 4 and 2. This is the x coordinate and then the y coordinate. So we start at 0, count the x coordinate, 1, 2, 3, 4, and then the y coordinate of 2, 1, 2, there it is. So B here, start at the x, negative 1, 2, 3, plus 1, 2, 3. So its coordinates would be negative 3x and then 3y there. C would be negative 2, and D would be positive 2 and then 0 because it doesn't rise above the axis. Moving forward, last week we were trying to make data points. So let's take a look at an equation and then how it relates to a table of values. Sylvia works at a garden nursery. She's paid $6 for every tray of tomatoes she plants. It says let n equal the number of trays that she plants and p her total pay. So her pay, is $6 times how many trays she plants. So if she plants 1 tray, 6 times 1 is 1. If she plants 2 trays, 6 times 2 is 2, or 6 times 2 is 12. If she plants 3 trays, 6 times 3 trays is $18. So here's the table. 0 trays, $0, 1 tray, $6, 2 trays, $12, and so forth. We notice this is going up by 1s, this is going up by 6s. We don't really need to continue doing a linear equation each time. We can just follow the pattern. But now we're taking it one step further. We're going to actually graph it. So here's the graph, x-axis, y-axis. If x is 0, then y is 0, 0, 0. If x is 1, then y is 6. X is 1, y is 6. If x is 2, then y is 12. If x is 3, then y is 18. So you can see we're going x, y, x, y, x, y. That's the run and the rise each time. So let's go to another example. Grade 8's going on a field trip. The bus has 24 students. If I want to know how many boys there are, I can just do this. I could say 24 students minus however many girls. Then I'd know how many boys. So G equals girls, B boys. How many boys are there? There's 24 total students minus the girls. Create a table. So it says, well, if out of the 24, 0 of them are girls, then that would mean that there's 24 boys. If out of 24, 1 of them is a girl, then the other 23 are boys, and so on and so forth. So what that means is you plug it in. So let's say there was 7 girls. So how many boys? Equals 24 minus 7. That would mean there would be 18 boys. So if we keep going, there would be 7 girls, 18 boys. We notice this is going up, 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 and down, down, down. This represents the same set of data. If there's 0 girls, 24 boys. If 0 girls, 24 boys. If 1 girl, 23. If 2 girls, 22, and so on. Next example. Now this is more closely related to what you did in 6.6. It says the equation of a linear equation is this. So once again we're doing if x is something, what would y equal? So let's go to our table. If x was minus 4, well, minus 4 times minus 4 would be 16 plus 1. So y would equal 17. If x is minus 4, then y would be 17. What if it was minus 3? Minus 4 times minus 3, well, that's 12 plus 1. Then y would equal 13. So if x is minus 3, y is 13. By the time you get to the third stage, you see a pattern. This is going up by 1 each time. This is minusing 4 each time. To plot this, though, you can't do it with a regular graph. You need a Cartesian plane because we have negatives. We now have an x and a y axis. So negative 4, 17, negative 4, and 17. Negative 4 on the x-axis, 17 on the y. Negative 3 on the x-axis, 13 on the y-axis. Negative 2 on the x-axis, 9 on the y-axis. Now let's go down to questions 1, 2, and 3 just to make sure we're solid. In example 1, can you have negative values for B and G? Well, in example 1, that's the boys, girls on the buses. Can I have negatives? Well, no, because I can't have negatives girls and negative a number of boys. So I know I can use a regular graph, not a Cartesian plane. In example 1, the relation is linear. That means it goes forward in a line, and the points lie on a line. Why don't we draw a line through the points? Drawing a line through the points is to extrapolate and find out where something is going. I don't think a line is necessary to extrapolate. We can clearly see the pattern of these dots, and a line is already inferred. And last, in example 1, the equation for the relation could have been the number of girls equals 24, or the total students, minus the number of boys. How would the table of values change? How would the graph change? Well, the table of values would be turned on its head. Let me explain. It would just be swapped. Instead, we would have, if there's 24 girls, there's 0 boys, 23 girls, 1 boy. And so we would simply have it reversed. But the table of values would only be flipped. It would not be any different. The graph would be identical, because still, if there's 24 girls, there would be 0 boys. If there's 23 girls, there would be 1 boy. So the graph itself would actually look exactly the same. These two variables are interdependent, and so how the data is arranged in the table or the graph does not change, because this variable and this variable are interlinked. Now, when I get to the end of a lesson, I in no way think that everyone has it 100% of the time. I expect some students have close to 100% of understanding, most students have most understanding, and some students are still struggling to try to get the initial concept. Don't be afraid to ask for questions. Always, if you're looking at a number, say number 4 is confusing me, go look for an example. Does number 4 look like example 1, 2, or 3? And if it looks like one of those, compare it and solve it. If not, ask for a friend, watch these videos again, or come in for some help with Mr. Ewert. I'm always there for you, and I look forward to having math discussions.